All right, so it says to use a double angle identity to change the form of this equation. So we've got x equals sine squared t. So we know that cos 2t is our double angle identity is 1 minus 2 sine squared t. And that's got sine squared t in it. So if I rearrange that, 2 sine squared t is 1 minus cos 2t. So sine squared t is a half minus a half cos 2t. And that's what our x is equal to. So you can see from that that our amplitude is a half. So we're going between, if we didn't have the plus a half at the front here, we would be going between a half and minus a half, but that adding that half, so that gives us the center. So we're pushing the whole graph up a half space. And so we've got the center, this is half is the amplitude. We also know the period using this. So remember the period is 2 pi on whatever the coefficient of t is, so in this case 2. So the period is pi. So if you think about it, if we were drawing it, we've got a negative cos curve, so it's the reflection in the x-axis of cos curve, but then it's gone up a half space. So if I drew it like you draw a negative cos curve, and we pushed it up, so that 0 is going up to a half. We'll just call this a half. And the periods are, the amplitudes are half, so that must be 0. And this must be at a half, so that must be 1. So you can see the range, the x value will go between 0 and 1. And you can see, so the period's pi, so that'll be pi on 2, etc. Do we need to know anything else? So we've got the center is a half, the amplitude is a half, the range is between, so x is between 0 and 1, and the period of motion is pi.